Hello, everyone. Welcome to the panel discussions of Innovation for Carbon Negative at the Microsoft Research Summit 2021. I'm very honored to host this session. My name is Tim Pan. I'm the Senior Outreach Director at Microsoft Research Asia. In this panel discussion, we will share insights on carbon negative innovation technologies and cutting-edge research from different perspectives, including policy, earth science, environmental science, and computer science. We will also discuss how to promote interdisciplinary collaboration, inspire more research novelty, attract future talent to the field, and turn good ideas into reality. Now I'm so excited to introduce you very distinguished panelists. Let me introduce them in alphabetical order. The first panelist is Professor Peng Gong. Wave at us, Professor Peng, who is the Vice President and Pro-Vice Chancellor in Academic Development of the University of Hong Kong. Professor Gong is a renowned scientist in earth science. Before he joined the University of Hong Kong, he held many important positions at Tsinghua University and UC Berkeley. Let's welcome Professor Gong. The second panelist is Professor Shuxiao Wang, who is the Director of State Environmental Protection Key Laboratory of Sources and Control of Air Pollution Complex. She's also a Changjiang Chair Professor and a Professor of School of Environment at Tsinghua University. Let's welcome Professor Wang. The third panelist is Dr. Tieyan Liu, who is an Assistant Managing Director at Microsoft Research Asia. Dr. Liu is an expert in machine learning. He is an IEEE Fellow, an adjunct professor at CMU, Tsinghua University, Nankai University, USTC, and an honorary professor at Nottingham University. Let's welcome Dr. Liu. The fourth panelist is Professor Yukari Takamura, who is a professor of Institute for Future Initiatives at the University of Tokyo. Her research focuses on legal and governance issues surrounding environmental agreements and seeking how these agreements could effectively tackle global environmental issues while accommodating imminent social and development needs. Let's welcome Professor Takamura. With all the experts in this area, I want to start my first question on behalf of the audience, of course, from Professor Wang. This is a tough question for you. You know, even today, some people still don't believe that there is a global warming, unfortunately. As an environmental scientist, can you just tell us how bad is the situation in terms of global warming?
Yeah, thank you. I would say it's as bad as you can imagine. So as reported by the sixth assessment report of IPCC, the Earth has warmed over 1.09 degree Celsius since pre-industrial times. So we have observed many changes, such as sea level rise and glacier melting, which are almost irreversible. So the scale of recent changes across the climate system are unprecedented over many countries to many thousands of years. For example, in 2019, the atmospheric carbon dioxide concentrations were higher than any time in the last 2 million years. So the global surface temperature has increased faster since 1970s than in any other 50-year period over the last 2,000 years. So we cannot only see that the temperature change, there are also other changes. For example, in the last 10 years, the annual average Arctic sea ice area reached its lowest level since at least 1850s. At the same time, the global mean sea level has risen faster than over any preceding century in the last 3,000 years. So extreme weather, as we all note, is on the rise. Hot extremes, heat waves, and heavy rains, such as we experienced in Henan province in China in last month, has become more frequent and intense across most land regions since 1950s. So we can definitely conclude that the human influence has warmed the atmosphere, the ocean, and the land. So the widespread and rapid changes in the air, in the ocean, in the biosphere have occurred. We cannot escape from the human-caused climate change. And so climate change is now affecting every continent, every region and ocean on the Earth. So I think we are at the turning point to make actions.
It sounds really scary. At least I'm scared. I mean, in your answer is you keep mentioning in 2,000 years, even you mentioned in million years. I mean, I think we are really in the devastating situation, and I think if we don't do anything, the future of the Earth, the future of human beings, will be really in huge trouble. So that lead me to the next question for Professor Takamura. I know you are an expert in policy, this international agreement and many things like that. So my question is like this. There are international agreements such as Paris Climate Accords, which was made in 2015, I think. There are national commitments such as President Xi pledged at the UN that China will strive to peak carbon dioxide emissions before 2030 and achieve carbon neutrality before 2060. And there are company-level commitments such as Microsoft's pledge that by 2030, Microsoft will be carbon negative, and by 2050, Microsoft will remove from the environment all the carbon the company has emitted, either directly or by electrical consumption, since it was founded in 1975. Okay, the agreements and the commitments, they all sound promising. So my tough question for you is, are you optimistic about these agreements and commitments, and why?
My answer is quite clear. Definitely, yes. I'm very much optimistic. As you all know, that the China's commitment, carbon neutrality by 2050, is very much welcomed by international society, and also all G7 countries, including Japan and plus European Union, commit themselves climate neutrality by 2050. So we have never had such a level of commitment from countries. According to the International Energy Agency and the other international organization, estimates show that our collective effort so far was estimated to not to change global pathway downward, even toward 2050. But with these commitment from China and the other country toward the climate neutrality by 2050 or closely very sooner, to this kind of commitment are expected collectively to push down emission pathway, global emission pathway, so that my answer is quite clear, and that is yes. And also many companies as Microsoft take its long-term goal and its clear commitment to the Paris long-term goal. So majority of, for instance, Japanese company now commit themselves to the climate neutrality by 2050. And even earlier, like Hitachi, and Hitachi is now commit to reduce their emission to zero by 2030. And also, like Microsoft, these companies also commit themselves to reduce emission from supply chain and value chain of its company. So big question is now how to convert these commitment of countries and company to actions and then reality.
Yeah, it sounds a lot more comforting after we heard from Professor Wang. So from your answer, both of your answer is, first, the situation is really, really bad. If we don't do anything, we'll be dead, right? And from Professor Takamura, which is a little bit, more confidence, is that we are glad we are doing something together. And personally, I also see this as a global movement, and it's very exciting. Now the next question will be like this. We know that we are all willing to do something, right? And but if you look at the commitments, it's not only carbon neutrality. For example, like for Microsoft, it commits that it will basically remove all the carbon it emitted in the history. So that means we really need new technologies to achieve those. So my next question is, suppose if there is no further innovation, okay, can we achieve those goals simply using the current technology we have? I think this is a relatively simple question, right? If we don't have other innovation, can we just complete those goals by what we have now? So I will give Professor Gong and Dr. Liu opportunity to answer this question first, if you have any comments.
I would like to start by saying that regardless what technology we have, it is always possible. The worst is we go back to where we came from. 200 years ago, before the Industrial Revolution, we are pretty much a carbon neutral society. So that's my bottom line answer. Of course, it's not that bad, that we don't really need to go back. And there are already existing technologies. It really depends on our political will and the public habits and adoption of and determination of the entire society. Put it this way. Right now, the major agents are contributing to the increase of carbon emission into our environment, are coming from fossil fuel burning. And in some of the countries that they are making substantial transformation of energy use or energy consumption, production, actually. You have to produce clean energy before you're able to use it. So indeed, we are heavily, as a whole in the world, still heavily dependent on fossil fuel use. But the technology is there. Hydro, nuclear, biofuels, and also solar and wind technologies. And there's big adoption in countries like China to adopt solar and wind energy production technologies. If you go to the west of China, large lands, tracts of lands are being covered by solar panels. And those are all contributing to today's energy consumption. And China has already promised to peak before 2030. And after that, I'm sure, even using today's technology, we can make a great amount of achievement. Of course, the issue is that we are also, you're giving us a boundary, without further technical innovation. I'm sure my colleagues will comment and you will ask us follow-up questions. I will remain silent about revealing future possibilities. Indeed, actually hydrogen, for example, hydrogen use is another current technology which will be help if we largely adopt new energies. So I'll stop here.
Okay. So Dr. Liu, you have any comment?
Yeah, thank you. So I actually have a little bit different opinion from Professor Gong. I think this is a really very complex problem because, it is not just purely to reduce their carbon emission to back to, for example, 3,000 years ago, because we need to solve a constrained multi-objective problem. We need to maintain the faster development of the economy as usual. We do not really want to slow down because we want to have a better society by the future. On the other hand, we need to have an affordable cost. We do not really want to use those too expensive technology, right? And at the same time, we want a sustainable society. We want to reduce the carbon. So that's a super complex problem. Given this complex setting, given the multiple objectives, I think there is still a very strong need for new technology. If we just bet on what we have today, it is, from my own opinion, very hard to achieve the ideal solution for that complex optimization problem. Yeah, that's my opinion.
Right. I think I agree with both of you because I think Professor Gong is trying to answer my question from a very extreme way. That means, yes, if you don't have technology, maybe you don't have pollution. Let's all go back to our ancestors' world. And of course, we don't want to do that. Okay, I think that is very reasonable derivative from what Professor Gong just suggested, that no one really want to go back to 300 years ago. Yes, of course. And I believe Professor Gong knows exactly what the follow-up question I may ask. That is, of course, we are not sitting here, right, and waiting to go back to 300 years ago. We are scientists. So my next question is for all of you. Everyone has to answer me. That is, in your research area, what are the most promising research that either you are doing or you heard that some other people are doing? Okay. Is there any good news, good excitement that you can share with all the audience? How about let's start from Professor Takamura.
To answer your question, I think the suggestion from the Professor Wang is very important. According to the IPCC recent report indicate that we need to keep temperature-wise as low as possible to limit adverse impact. For doing so, we need to limit emission that we are actually emitting in the atmosphere as, less as possible. So I think that we need two directions to tackle climate change. First, do emission reduction as much as possible from from now and accelerate these actions. For doing so, we need the innovation of technology that are available to us. From policy perspective, then, how to diffuse these technologies, how to, for instance, make them more cost effective. So that is how we can, promote this kind of technological change. The second direction that I found necessary is that of course, carbon neutrality and reduce emission is a quite challenging task. we need new technology so that how to, accelerate the research and development of new technology to contribute to make our society to net zero. So I think then from policy perspective, I think one of the most important area is technology policy on technology. And as I said, that to diffuse current technologies and also to make accelerate the innovation and research and development of new technologies.
Thank you so much. And Professor Takamura says about how to accelerate the development of the new technologies. And of course, I look at the other three panelists. You are all in the area of technology. So let's start from Professor Gong. You are having a team working on earth science. Is there any good news or any good idea you have been doing recently?
I myself work with a lot of people, but I only contribute a small part into the big picture. But I do think that there are lots of exciting, if provided, more societal resources are input into this particular field. We have a lot of possibilities. The area that I work is actually more on nature-based solution. We all know we emit industrial activities and living, emit a lot of carbons into the atmosphere. And then it's being sucked by plants on Earth and also by the ocean. So the partition of that is 44% remains in the atmosphere. About 29% are being absorbed by plants, either on land and also actually in the ocean, phytoplanktons. And also the ocean itself absorbs as the pressure of the partial pressure of carbon dioxide are being increasing in the atmosphere. The ocean is actually passively absorbing some part of that. So 22% of that. So nature-based solution is trying to contribute to the solving of this puzzle in a few ways. I always want to imagine that if we reduce carbon emission in the atmosphere while the plants are still being able to absorb about a similar amount of carbon emission. So that would mean that the proportion from today is 29%. There are uncertainties in the calculation. I have to say that if you recall from my 44%, 29%, and 21%, there are about 7% or so which we don't really know where it has gone to. There are people who are guessing, the absorption, the uncertain part. So that's where science is important. We are trying to figure out, where the missing carbon have gone. But on the nature-based solution side, that we still hope that we are able to learn and study better about how can we increase plant productivity by, afforestation, for example, in terms of increasing the area, by reducing in the ocean the dead zones right now caused by pollution and over-nutrification. So there are lots of questions that are need to be addressed with more research, and that's where that we could play a big role.
Yes, I think this this sounds really exciting, you just keep mentioning nature-based solutions. I think as a computer scientist myself, we always tend to use so-called technology, right, to kind of invade and tackle the problem or things like that. But it seems to me that you are talking about the nature. Actually, you somehow use the nature to absorb the excessive carbon. So may I ask a little bit deeper? Is that you mentioned about all the percentage of the land, the plant, the sea being able to absorb those carbon, but to me, changing the nature is extremely difficult, right? I mean, in terms of using electrical or computer science problems, you just get the equipment and then absorb the carbon. Okay, that's easier to imagine. But in terms of nature-based solutions, how are you going to alter what the nature is doing now and then increase, say, the efficiency of the nature to absorb more carbon? How do you do that? What is the magic in here?
Well, that's why I didn't really say that we try to increase a significant amount of nature, but I did mention one thing. I could actually add a couple more. So the one thing I said is everything plays in a relative term, but Mother Nature let's just concentrate on the amount of area that are occupied by green vegetation. We are expanding our urban areas and agricultural areas into the natural vegetation. So we reduce natural plants in area. On the other hand, there are many, more subtle mechanisms that people are still studying. For example, we increase the amount of carbon concentration in the atmosphere, and that actually, the increased concentration is serving like a neutralification, what they call, you are giving more carbon to promote photosynthesis. So to increase the photosynthesis capacity. There are other ways that you can make photosynthesis more active. For example, if there are ways that we could make plants to absorb more sunlight, they will carbon sequestrate more carbon from the atmosphere. So that's one point. Another additional point is, of course, if we somehow could refurbish our land use rather than keep converting or even increasing the natural plant vegetation area instead of reducing it, then we are helping Mother Nature to absorb more carbon. Some ways like actually the efforts to reduce desertification is helping greening some less productive lands, but still they're going to help suck up more carbon. Another thing is that if we can help prevent prevent fire, wildland fire as a disturbing factor. If we can reduce that, we are also able to increase the carbon sequestrated by the natural system. So those are the kind of ways. And also greening up our rooftops in cities can also help, increase the sequestration of carbon. So there are many ways that those are all contributing to nature-based solution.
Thank you so much. I'm fully convinced by the examples you give. Yeah, actually, there are a lot of things we can do together, okay, at least to green this environment. That will help. Okay, and then Professor Wang is in environmental science. So this is really your major, right? What are the exciting areas for research in environmental science?
I would say that the most important way to combat the climate change issue is still that to reduce the anthropogenic carbon dioxide emissions and other greenhouse gases emissions. In this point, that is very important to establish a low carbon or zero carbon power generation system. So we are happy to see the development of renewable energy technologies, energy storage technologies, and smart grid systems. So those are very useful. But here I want to emphasize that, as an environmental scientist, we always look at this issue in a broad way. So we consider the climate change issue together with other environmental issues. For example, air pollution issues and the waste recycling. So in this case, I think China's efforts to reduce carbon dioxide emissions can work closely with its campaigns to clean the air. You all know that yesterday the WHO released the new air quality guidance, so which is a new start for us and a big challenge. So to realize such air quality targets, we cannot only rely on the end-of-pipe control techniques. We need to establish almost a zero carbon power system. I think that's one right way to go. And second is that I'm very excited that to see the computer science or the big data techniques are playing a role in reducing the carbon emissions. For example, by improving the fuel efficiency and the operational efficiency using AI and machine learning, and we can reduce the transportation logistics operations, their carbon footprint. Of course, this can be applied to many aspects of our society to identify, which area we have potential to further reduce the carbon emissions.
Okay, thank you. Professor Wang actually give a starting point for Dr. Liu, because the next one I want to ask is Dr. Liu, who is the computer scientist. But I want to somehow combine the current question, which is the research in your area, with the next question, which is read like this: carbon neutrality is an interdisciplinary subject, and I know that your group has done a lot of collaborative innovation on all different kind of topics. So can you share with us your experience and how computer technology can help achieve carbon neutrality? So in this question, okay, we are colleagues, so I'm tougher on you. So in this question, it's not only how computer technology can help in this carbon neutrality, but also what you, especially your team, in the Microsoft Research Asia, what your team has been working with all the different disciplines, especially in environmental science, in earth science. What have you done in recent years?
So the first question is about the promising research ideas in our field, because I represent computer science and artificial intelligence. So from my eyes, I think the fundamental way to tackle the carbon challenge is really to develop a clean energy and carbon capture or storage technologies. But these technologies are not very mature yet, as everyone knows, and there is a strong need to solve some fundamental scientific problems first, such as the efficient solutions to the, for example, Navier-Stokes equations to understand the diffusion of pollutants and the global warming effect, as well as the efficient DFT calculation for catalyst design, battery material design, or carbon storage site selection. But as we all know, the numerical solvers for these equations are very time-consuming, and somehow they cannot scale to large systems. So here I believe a very promising research direction is to use artificial intelligence to accelerate the solution of these equations, hopefully by several orders of magnitude. If this could be done, we will be able to perform very fast simulation for the physical systems, for the chemical reactions, and then lay down a solid foundation for carbon neutrality. So quite a few research organizations, including Microsoft, have already started to look into this important direction. For example, researchers at Microsoft Research Asia, we have put quite a lot of efforts on this. Our early research explorations show that AI-based PDE solver could be faster than traditional numerical solver by almost 100 times. And AI-accelerated DFT calculation could be faster than standard DFT by more than 10 times. And furthermore, end-to-end AI models could be even faster, say 6 or 7 orders of magnitude of acceleration. We are working very hard to make this research more robust and scalable so as to transform the industry of energy and sustainability. And this also naturally links to the second question Tim asked. Yes, over the past several years, my group has been working with researchers from diverse scientific disciplines, such as biology, environmental science, and physics, as well as experts from different industries, such as healthcare, finance, logistics, energy, and others. What I learned through this kind of collaboration is that the huge opportunity for AI to transform all these scientific fields and the industrial domains is there. And if we have well-designed deep learning and reinforcement learning methods, we have the potential to disrupt those areas by significantly improving the efficiency and effectiveness of traditional approaches. But in order to achieve this kind of disruption, people from different fields must work very closely together with each other and have to have kind of an open mind. We need to trust and respect each other, and we need to be willing to learn others' languages and domain knowledge and also share our own. Let me give you some very quick successful story. We once worked very closely with the domain experts in a world-leading shipping company and reduced their carbon emissions significantly. We actually developed a reinforcement learning-based approach to replace their previous operations research-based approach for repositioning their containers. That saved a lot of operational cost. For another example, recently we worked very closely with a professor in the Tokyo University on a deep learning model to simulate the hydrate growth for carbon storage, which could accelerate the traditional simulation by over 1,000 times while keeping an accuracy of 99.5%. I firmly believe all these AI solutions could play a more and more important role in the future so as to contribute to the tackling of the carbon challenge. Yeah, Tim, back to you.
I heard, and actually personally I experienced, that cross-disciplinary collaboration is very difficult. I mean, because sometimes we don't even speak the same language. For your experience, especially for the past few years, right? You said that you have been working with medicine, with environment, with so many cross-disciplinary collaboration. How do you really solve the difficulty in terms of, say, people speaking different languages in different disciplines? How do you really, especially I know you can do that, but how about your team members? How do you just encourage your team members to really work on different areas, right? Or your members are computer scientists. How do you make them willing to learn something which they don't think that's their major? How do you encourage them to do that?
Yes, I think it's really hard to change people's mind. For example, someone who are not really open enough to learn new things or to work with people from other disciplines, that is going to be hard. I think what we have done here in MSRA is really to identify the right people who are willing to collaborate, willing to learn. And also we want to educate the potential customers or partners that our AI technology can really help them. So by having more and more such a successful story, and we see a trend that more partners are willing to embrace this kind of AI disruption, AI era, so that, from both sides, if we can come closer together and have some chemical reaction between us, the process of collaboration will become easier and easier.
And I know someone in this panel also has a lot of experience. Working cross-disciplinary, who is Professor Gong. The first time I visited Professor Gong's Earth Science Center at Tsinghua University, I was so impressed because his team members include really the world's top computer scientists. So Professor Gong, could you also elaborate a little bit about how to make this cross-disciplinary team truly work together?
I quite like Professor Liu's comment about you really need to interest-based. You need to mutual select. Not, if somebody who is only wishing to work on his or her own field rather than, expanding into others' comfort, into his or her own comfort zone, then it is very hard indeed. But we are fortunate also. Actually, I'm quite happy. I'm sure Professor Shuxiao Wang is also happy to see from outside to observe the development of Earth system science. First, I'd like to recap a little bit about the great contribution of technology, including computer technology, in solving today's great challenges we're facing. One way that we are, Professor Liu mentioned about computer simulation. That's a big amount of work that we do at the Earth System Science. We simulate the global climate. We simulate the whole Earth system on the surface. We didn't really do much about the structural and internal Earth system. But on the Earth's surface, we try to put together models, very complicated. Millions of lines of codes are involved, which requires huge computing power to solve our puzzles. Now, we can do this through computer system, but we cannot do it in reality. Just as simple as that. A lot of things that when we have good ideas, we try to test it out. There's no way we can do it on human or for the whole society to act unless we know exactly the right direction we are going to accomplish. That's why it is important to use computers to design various kind of experiment to assess policies for action. So realizing the need for people coming from different disciplines to work together, our task was to actually attract people from different disciplines to work under one roof. With that, we are able to understand each other better. The reason I'm saying that Professor Shuxiao Wang will be happy is, earlier, at the beginning of this Earth System Science program at Tsinghua, the first experiment we did is to invite a computer scientist to help basically fine-tune one internationally highly respected code called GeoChem, which studies, basically simulates atmospheric constituents transport. So it was developed originally by domain experts like Professor Shuxiao Wang. But the efficiency was improved after the computer scientist working on it. It's 70 times faster. So just by, working very simply, having colleagues from two different disciplines working together to improve the computing efficiency. So today we are observing that we are actually harvesting the fruit from the cross-disciplinary collaboration between computer scientists and also earth scientists. And this year, some of my colleagues have been able to publish works on the use of deep learning technologies, AI technologies, to fine-tune some of the originally Earth system models based on mechanism. Now they're using big data and also using deep learning to parameterize the models. And those models are much faster, and they are able to provide hints for new insights in the model testing. While we're doing the experiment with computer systems, we're not only assessing policies, we're also develop insights in further improvement on the mechanism side of the models, help us to improve our understanding of how Mother Earth works. So that's the power of cross-disciplinary collaboration.
I'm totally overwhelmed that professors in earth science publishing machine learning AI papers, and Dr. Liu having a machine learning team at Microsoft Research, and they recently published paper in a very famous environment science journal. I think this is really the true spirit of cross-disciplinary, and we believe this carbon neutrality is this kind of problem that really needs cross-disciplinary collaboration. Yes, Professor Gong.
May I add two results? We have in the Earth System Science Department 5 computer scientists. Their original background is all their training are from computer science. And this year, 2 of them win China's distinguished scholar is young distinguished scientist award under age of 45, and from the Chinese National Science Foundation. They both are computer scientists, and one is earning this award from cross-disciplinary field, and the other actually is winning the award from earth science. So that's basically is another evidence of the good fruit of cross-disciplinary collaboration.
Super. Okay, now because of time, we can continue talking about this for hours and hours, since this is really a very important and very interesting topic that attracts everyone's attention. Because of time, let's make a conclusion. So I'll give every one of you 30 seconds to give a very short remark as your conclusion for today's discussion. May I start from Professor Takamura?
So thank you, Tim. Very interesting discussion. I say that of course, the climate carbon neutrality is a really hard and ambitious goal, but we definitely need fast technology and policy which support its development and diffusion. And also we accelerate the people's mind, the society value, to support technology innovation and also policy innovation. So that's a message that I like to send.
Thank you. Professor Wang?
I hope that in the future there will be more interdisciplinary cooperations, not only between the different scientists, such as Professor Gong said, earth science, computer science, but also between the scientists among natural science, engineering science, and social science, and also further collaborations between industries and governments and the research institutes.
And Professor Gong?
Okay, we need change. We all need a change. All humankind. We need to live in a more thrifting way. We need to act gentler and better towards a common good, which is the air, water, and our common environment. So today we talk about carbon neutrality, but the whole thing is this urgent lesson will make us to think differently about Mother Nature. I hope we all not only think, but also act.
Dr. Liu?
So I think a carbon reduction is not just something nice to have. It is something that we need to take very seriously and put a significant R&D efforts on. So this is not a simple task and it needs to involve people from different disciplines, industry, and different countries. Only in this way, we could have the opportunity to define the right problem, polish the idea, validate the method, and ultimately deploy a useful solution. So while this is not easy, I'm quite optimistic about the potential of our people and our technologies. I think let's just do our best to do it, to achieve it.
Thank you so much. And just a short conclusion is that in this short 50-minute panel discussion, we heard from Professor Wang that this global warming is really a serious problem. And if we don't do anything, we are deeply, deeply in trouble for the whole Earth and human beings. And we heard from Professor Tamakura that the bright side is that we are having this international collaboration, this agreement, this commitment from the government as well as from the private sectors. And we heard from all the professors, especially from Professor Gong, Dr. Liu, that we are having more and more innovative research and technologies coming out. And we are so glad that computer science can really help in this carbon neutrality. And finally, from all the conclusions of the professors, we should really turn these ideas and what we expect into reality. Let's start, do something. Thank you so much.